So I'm going to talk today about curiosity, and not the rover. You have another talk about the rover. In 1994, a comet came very, very close to Jupiter. So close that because of Jupiter's gravity, it broke it to some 24 fragments like this. And we took this image with the Hubble Space Telescope. We called it the string of pearls. And we calculated that each one of these fragments was going to hit the atmosphere of Jupiter, one by one. But we had no idea whether we will actually see anything, because simulations showed that if these fragments were smaller than maybe half a mile or so, they would just go in and you would not see anything. You know, like you throw a small pebble into a pond, nothing happens. So there we were, all gathered around an old computer screen. I'm there too, sort of kind of at the top with much darker hair, so maybe you don't recognize me. When the first fragment was about to hit, and we wanted to know what's happening. And, you know, if I had to give a title to this photo, which was taken by a journalist without us knowing, I would call this photo Curiosity. This is what this photograph is all about. It shows, in this particular case, scientific curiosity. Now, as soon as I saw this picture, I happen to be an art fanatic as well. It reminded me of a painting that was painted some almost 400 years before that. It's called A Lesson in Anatomy by Rembrandt. And look at that. Rembrandt really didn't care about the corpse that's there. All he cared is about the curiosity on the faces of the people around. I mean, just take a look at these two images. One, two. It's the same picture, right? It's a picture of curiosity. By the way, if you're curious to know what we actually saw, then here it is. We first saw a point of light that became bigger, mushroomed, and fell back onto Jupiter's surface. Basically, it was almost like a nuclear mushroom rising above Jupiter's surface as the first fragment hit. And actually, those fragments, they left scars in the atmosphere of Jupiter, which stayed there for months, and we followed them, and we could study how the motions are in the atmosphere of Jupiter. Now, when is it that we get curious? Broadly speaking, there are two types of things that really get us curious. I mean, there are details, but broadly speaking, one type of thing that gets us curious is things that really surprise us. Things where, you know, we have a certain picture of how things should be, and something comes out that it's not quite like that. You know, I show you these crooked circles there, that's not very interesting. If I tell you these are perfect circles that are concentric, you say, no way. But here I can plot on them perfect circles, and you see that they are. That is now surprising. You know, why is it like that? We would like to know what that is. A second thing that doesn't fail to surprise us is extreme outliers, things that don't conform. You know, something like this. You know, this always surprises us. Why is that? So, extreme outliers make us curious. There is a second thing that makes us extremely curious, and this is what you might call confounded evidence, which basically means something like this. You see something, there is a possible explanation, but there are other possible explanations, and you don't know which one is right. There are several possible theories. There are several possible continuations of the story, you know, and so on, and you don't know which one actually works. Do you recognize this? Does anybody recognize this film? Which one is it? Casablanca, of course. I'm going to show you a few seconds from this film, okay? Just a few seconds. So, you know, there may be a younger population here who have not watched Casablanca, but, you know, most people have seen Casablanca. So here is now that scene.
That train leaves the ground and you're not with them, you regret it. Maybe not today, maybe not tomorrow, but soon and for the rest of your life. What about that?
And then, when she says, but what about us? The computer starts buffering, the power goes off, you don't know what he answers. You know, this is just horrible. I mean, you have 217 possible continuations to this story. Now, does anybody actually know the line that he answers here? will always have Paris, one of the best lines in the film. So that's the kind of thing where you have confounded evidence. Another thing which psychologists actually like to use is they show you a picture that's blurry. And they ask you to think what it is. What is this? Like, what do you think this might be?
A balloon.
A balloon. Okay, somebody else? Saturn. Okay. Well, actually, let's see. It's a pearl on the neck of Marilyn Monroe. So, confounded evidence. It could be this, it could be that. We don't know. These are the types of things that make us curious. Now, so I mentioned two things. Things that surprise us, confounded evidence. Now, what happens in our brain when we're curious? If you asked these questions 50 years ago, somebody would tell, what do I know? You can do these experiments in psychology. They tell us something about how our mind works. But what actually happens inside our brain, we couldn't tell. But now we can, because you can take people and you can stick them into a functional MRI machine, make them curious by one of those, pictures, confounded evidence, and you check which regions in the brain light up when they actually are curious. And they find that these regions light up. Now, these regions are associated with hunger, with conflict. So we are kind of hungry for knowledge. Philosopher Thomas Hobbes once used to say, there is a lust for knowledge. And conflict, when this confounded evidence, we cannot tell. These are the regions that light up. Now, what happens when we satisfy the curiosity? Like, I showed you that picture and then showed you what it actually was. Then, this region lights up. This region in the brain is associated with the pleasure circuit. It lights up when we have good food, good wine. So being curious is like being hungry. Plato, he was one of the smartest people who ever lived. Philosopher Alfred North Whitehead once wrote that all of Western philosophy is a series of footnotes to Plato. Plato, in his dialogue Meno, he asks the following question. He says, I'm paraphrasing a bit, but he poses this paradox. He says, when are we actually curious? You see, if I don't know anything about something, then I don't know what to be curious about, and I won't be curious. If I know everything about something, then I already know everything, and there is nothing to be curious about. So when is it that I get curious? He actually hit exactly upon what these psychologists are finding. Namely, if I plot knowledge one way and curiosity the other, you get something like an inverted U shape. Namely, when you know very little, you're not curious. When you know a lot, you're not curious. You're curious when there is a gap between what you know and what you think could be known about this thing. That's when you really get curious. Curiosity is what drives scientific research. This is the James Webb Space Telescope that we're now building, to see the very first galaxies in the universe. Some people say, no, it only drives basic research, not applied research. You know what? On this, I'm like my friend Martin Rees, who says there are two kinds of research. There is applied research, and there is not yet applied research. Then it drives education. Yes, we heard so much about education. How do you make kids learn? By making them curious. That's the thing you really want to do. Make them curious. So, they say that curiosity is contagious. What I say to that, well, in that case, let's make it into an epidemic. Thank you very much.